All right, so now let's look at part 4 of this awesome topic, composite figures. We're still continuing on measuring, and so we're going to measure this figure here, which is composed of a square and a trapezoid. Okay? So then let's find the square first. It's a square, and they want you to use the nearest quarter of an inch. And so if I measure nearest quarter of an inch, well, that's about 1/4. That's half, and that's 3/4. So then it's about 0.75 inches. And since it's a square, I know that each side is 0.75 inches because all sides are the same in a square. Okay, now we can figure out the other figure, which is a trapezoid. Obviously, we have one of the bases already. The trapezoid is the same as the side of a square. And so now let's find the other one. Well, we have a little over 1, because 1's here, and then we go all the way over here as well. That's about 1 1/4, about 1.5. So 1.5 inches. Now we need a height for our trapezoid. If you look at the picture there, trapezoid base 1, base 2. Oh, I'm sorry, base 1, base 2. And then the height is perpendicular to both bases. In other words, it touches at a 90-degree angle. So it's not this one. This is a slant height, and this is an acute angle when they touch each other. Can't be that one, so it has to be this one. So that means that I'm going to measure this one here. And that measures about 0.25, 0.5, and 0.75. So this is 0.75. And so now what I can do is use the formulas, which is area is equal to base times height. So base times height. Base times height. So I'm going to put there 0.75 times 0.75. Okay, so I'm going to use the calculator for this one. So 0.75 times 0.75, because base times height. So 0.75 times 0.75 gives me 0.5625. But I'm going to round up to nearest tenths. I'm sorry, the nearest hundreds. So tenths, hundredths. This one here, 5 or more, we add 1 more. 4 or less, we let it rest. So we're going to keep it at 0.56 instead of moving it to 0.57. So this is 0.56 square inches. Okay, so it's 0.56 square inches. This is the area of the square. That was the square. Okay, so now we need to find the area of the rectangle. I'm sorry, the trapezoid. And for the trapezoid, we use the equation base 1 plus base 2 times the height divided by 2. And so now let's find our bases, and our bases, just like you see here, our bases are opposite of each other, and they're parallel to each other. Okay, and they're perpendicular to the base, to the height. So I look there, right, make it face this way, sideways. You can see base 1, base 2, and the height is perpendicular to both bases, and the bases are parallel to each other. So then those are my bases. So I'm going to put there base 1 equals 0.75, base 2 equals 1.5, and then the height is equal to 0.75. And so I'm going to input that into my equation, which is right here. So I'm going to put, okay, I went from here to here, and I'm going to go over here. 0.75 plus 1.5 times 0.75 divided by 2. So I'm going to put that in the calculator because, well, I can do this. 1.5 plus 0.75 is 2.25 times 0.75 divided by 2. And so this gives me 2.25 times 0.75 equals, divided by 2, gives me 0.84375. So then I look here, I want to the nearest hundredths. So 5 or more, we add 1 more. 4 or less, we let it rest. So I'm going to leave it at 0.84. And so this equals 0.84 square inches. So that means that this answer is for the trapezoid. Okay? And so now what you're going to do is you're going to add both of these answers up, line up your decimals, and see which is the best choice. But you must show this work Okay, add them up and then figure out the answer. Okay, go to the next one. Okay, this one here, the model of the front of a steel beam is composed of two rectangles, so that's key. Two rectangles and a square. Okay. Obviously, for rectangle and squares, we use rectangle base times height. Square is the same as base times height. So then we go here and we're gonna measure. It says use a ruler to the nearest quarter of an inch. Okay. So then we'll go here and I measure, and that's 1, 1.25, 1.5, 1.75, 1.75. Okay, all inches. And then this one measures about 0.25 inches. Okay. And now, because it says two rectangles, I'm assuming, and we can check that these two rectangles are congruent, also because they're parallel to each other. So I'm not going to assume. I'm going to use the rules that we have in place, and I can double check here, and I can see that it is 1.75, and I can see that it is about 0.5. I'm sorry, about 0.25, a quarter. And so that means that these are parallel to each other, so they're congruent. So that means that this one is also 1.75, and this one is 0.25. Well, now we need to measure the square, and the square measures, that's about 0.5. And so if this is 0.5, that means this is also 0.5, because that's the square. And so then I know the formula is going to be used on this one is base times height. For everything, because it's rectangles and squares, so we use base times height. So this would be base times height, so 0.5 times 0.5. Well, 5 times 5 is 25, and two numbers to the right of the decimals means that you have 0.25 square inches. That is the area of the square. So make sure we understand this is the area of the square. This one here. Okay, area of the square. And so that tells me that this is 0.25 square inches. Now I need to find the area of this rectangle. And the rectangle is just base times height, 1.75 times 0.25, which gives me 1.75 times 0.25, and get 0.4. Now am I going to put 4443? I want to the nearest hundreds. 5 or more, we add one more. So we're going to put 0.44 square inches. This is the area of one of the rectangles. That's one rectangle, but you have two of them. You have one rectangle, one rectangle. Okay, so you must add all the three areas together. Just don't forget that you have one area of the square. This is the area of the rectangle, and this is the area of this other rectangle. So add up all your three, the area of all the three faces, and you'll get the answer. Next one here. You have a rectangle and 4 semicircles. Okay. A rectangle, 4 semicircles. It says there, what is the best estimate of the area of the unshaded region? In this case, in all these other problems, we've been adding to get the answer. Well, in this case, because it wants the unshaded, in other words, it just wants a section of it, we're going to subtract. Because they just want a piece of it. They don't want the whole thing. They just want the area of the white part, the unshaded part. So that means we got to get rid of these circles. That means we got to subtract them. And it has the word best estimate. So for pi, we're going to use 3. Because it says best estimate. And so now, I need to find out the rectangle. So let's see what the rectangle measures. And we're going to use centimeters, so we're going to be a little more precise. And this is about 4.5. So we'll go with 4.5. And this is about, let's see here, it's about 5.5. So this is about 5.5. Okay. And so now we need to find the area of the rectangle altogether, base times height. So it's 4.5 times 5.5. That'll give me 4.5 times 5.5. 24.75 square centimeters. Okay, that's the area of the whole rectangle. But I don't want the whole rectangle, I just want the unshaded region. So then I gotta figure out these half circles. And so I'm gonna measure in centimeters, and that's about 2.5. So we're gonna put there 2.5. Okay, and they're all the same, 2.5. But we only need one of them to figure out the whole answer. For example, these two half circles can be put together and make one circle. So, and then these two make another circle. So actually we have two circles. 4 half circles make 2 circles. And so let's use our formula. Okay. Things run out of ink or something. Okay. So area equals pi times radius squared, which means area equals pi times radius. Okay. And so we know what the radius is. The radius is like this. This is the radius. That is from the center point to the outside. So if I had my whole circle here, let's just say I had the whole circle. As you can see, the 2.5 represents the point from the outside all the way through the center point and all the way to the other side. So that's not my radius, because my radius is from the center to the outside. The diameter is the one that comes all the way across through the center, from one side to the other side. That's what this is. That's the diameter. So the diameter for this one is 2.5. Well, the radius is half of that. So the radius is 1.25. So then that's what I'm going to input in this equation. And pi is going to be 3, because best estimate. So 3 times 1.25 times 1.25. And so that gives me 3 times 1.25 times 1.25. Oh, sorry. 3 times 1.25 times 1.25. That gives me 4.6875. Rounded off to nearest hundreds. So this is going to be 4.69. So this gives 4.69 square centimeters. Okay. What am I going to do now? Well, this is the whole circle, one circle. And this is the area of the rectangle. Okay. So what I'm going to do is I'm going to subtract, because it says the unshaded part. So I'm going to subtract this from my 2 circles. This is for one circle. Okay. So this is one circle. Well, it's kind of hard to take because this pen's not working correctly. Just remember, this is one circle. You have 2 circles. Each one measures 4.69. 4.69 and 4.69. You're going to subtract that from this, and that'll give you your answer. Number 16 there, we have 3 rectangles inside a parallelogram. So 3 rectangles inside a parallelogram. Let's measure, because we gotta measure. Nearest half of a centimeter. And so I'm gonna measure here. This is about 6.5. I can see there, closer to 6.5 to the nearest half. Okay. Now I'm not gonna measure this because that's not the height. If you look exactly at the parallelogram, the parallel is the base, and this is not a height because that's not a right angle. The height has to be perpendicular to the base. You see? Right angle. So then I'm going to measure the one that comes down this way. And that's my height. And that measures about 3.5. So this one here is about 3.5 centimeters. Okay. And so how do we find the area of a parallelogram? Well, you have it there. Base times height. So we're going to multiply 6.5 times 3.5. Okay, that's going to give me 6.5 times 3.5, 22.75. Of course, you're going to think, is that the answer because it's 23? Well, no, you haven't. Look what it says, closest. Yeah, it's the closest to that. But you still haven't, they don't want the area of the parallelogram. They say they want the area of the unshaded part here. Look, what is this? Which measurement is the area of the unshaded region? So when they want the shaded or unshaded, you have to subtract. So you're gonna subtract. Well, first then you gotta find the area of those three rectangles, and let's see what the base is. The base is about 2, and so we use 2 centimeters. And this one's roughly about 0.7 around there. So we're gonna go with 1, and they have to be congruent, and I can see they are. Okay. Didn't say, so I'm checking, and it's roughly about 2 there, and it's más o menos. It's about 1, okay? And so we're gonna say that's 2 and that's 1, 2 and 1. It's all in centimeters. Okay. So think there, how do you find the area of a rectangle? Base times height. So then all I'm gonna do is base times height, base times height, base times height. What am I gonna do now? I'm gonna subtract. This is the total for all the parallelogram. I'm gonna subtract this, subtract this for these 3 from here, okay? So this minus these 3 rectangles. You have the dimensions. You should be able to get these answers very fast. Find the total of these 3 and subtract it from this total, and you'll get the answer. Okay, good luck. Adios.